Sample problem. We connect a capacitor C1 equals 8 microfarad to a power supply and charge it to a potential difference of 120 volts. It is then disconnected to the power supply, thus leaving the capacitor charged. The charged capacitor is then connected to an unchanged arced capacitor with a capacitance of C2 equals 4 microfarad. Letter A, what is the initial charge of the first capacitor after it is charged by a power supply? Letter B, what is the stored energy of C1? Letter C, after charging capacitor 2 where there is no more current flow, what is the electric potential difference across each capacitor and what are the charges in each capacitor? Letter D, what is the final energy of the system? For letter A, the initial charge Q0 of the first capacitor after it is charged by a power supply is done by using equation 1. We get that it is 960 microcoulomb. For letter B, to find the stored energy of C1 we use equation 14 and we get that the initial potential energy is 0.0576 joules. For letter C, when the switch the positive charge is distributed with both plates. We see some of the charges migrate to the other plate due to difference in potential but eventually halt. Since the capacitors are in parallel connection, then their electric potential or voltages are the same. Using equation 1 we get that the electric potential across each capacitor is 80 volts. Now we determine the individual charge using equation 1. We see that charge 1 is 640 microcoulomb. And charge 2 is 320 microcoulomb. For letter D, the final energy of the system is done by using equation 14. We see that it is 0.0384 joules. We see that the final potential energy is less than the initial potential energy. The other energy is converted into some other energy such as heat.